Hi, welcome to the midweek Space News Roundup, and let's get straight into it with this first story. I put myself in the corner. This is the late breaking news from the Impulse Space company, and they have just announced they are working on a lunar lander, and they have a few renders. So we're just going to go over the news article where they announced what they're working on. They say our work to improve in-space mobility doesn't end at geostationary orbit. That's why we're unveiling some of our initial plans for the next stages of our roadmap, starting with the moon. You can see a render there. You have the Helios kick stage, and then you have this new vehicle, which is a lunar lander, heading towards the moon. Impulse made lunar lander. So their lunar vision, they go into their vision for the moon and for the enduring human presence on the moon. They say that's a critical gap in lunar cargo delivery capabilities for payloads in the mid-size range. That's from 0.5 ton to 13 tons. So very small payloads can be launched on existing landers. You have landers from Intuitive Machines, Firefly, Blue Ghost. You have iSpace, and other companies working on small lunar landers. And then, of course, you have the very large landers, such as the crewed landers for the human landing system. They can land many, many, many tons. So it's the mid-range that Impulse Space are targeting, which is between 0.5 and 13 tons. And they say, for instance, that will cover things like lunar terrain vehicles, rovers, communication relay systems, power generators, and habitation modules. And they go on to say we need landers capable of near-term, multi-ton cargo deliveries in order to rapidly build out a sustainable lunar presence. And their new lander is to be developed by our team in-house. And the mission architecture doesn't require in-space refueling, which for the larger landers from SpaceX, Starship, and from Blue Origin, the Mark II, both require in-space refueling. Which is great. I mean, it's great for capability and Delta V. The downside is it's more complicated and difficult to do. The lunar lander from Impulse Space doesn't require any kind of refueling. Once launched, it can then go directly towards the moon and land on the moon. They want to kickstart infrastructure, resource utilization, and economic activities on the moon. And they're estimating they can deliver up to 6 tons of payload mass to the moon. That's across 2 missions per year starting in 2028. So each lander can deliver 3 tons, which is similar to Blue Origin's Mark I, which is also 3 tons, but they expect to be able to launch 2 missions per year, so a total of 6 tons of mass to the lunar surface from 2028 from then on, I guess. They then talk about why they've got some advantages over the other companies. They're using existing and flight-proven launch vehicles. They've already flown their space dogs, the Helios kick stage and the Mirror kick stage. So they've already got flight-proven hardware working in space. And they've already begun work on the engine for the lunar lander. And here's an interesting point. The lunar lander uses nitrous and ethane bipropellant, alleviating any risk of boil-off during extended missions. So the issue with using hydrogen and oxygen or any cryogenic fuels, also like liquid methane and oxygen, is they have to be kept extremely cold because of cryogenic. If you don't keep them cold, they just vent off, they boil off. And you can lose something between 1 to 5% of all the fuel in a day. So it requires complicated systems to keep them cool, but that's not the case with Impulse Space. The choice of fuel and oxidizer, which is nitrous oxide and ethane, doesn't boil off. So lunar lander can loiter in space for months and months and months and then land as needed. So that's a big advantage. The moon can serve as the site of a sustained human presence in space. So that's very interesting, and that news just broke the other day. So Tom Mueller is the CEO of Impulse Space, and he is also the employee number 1 at SpaceX. He developed the Falcon engine, so he's an expert when it comes to engines. Okay, let's move on to the second story this week. Bring it up. And this is from Blue Origin. Sims today, lunar South Pole soon. we're getting close to the final stretch of training for our first Blue Moon Mark 1 mission. This month we're running end-to-end high-fidelity demonstrations of several mission phases: launch, apogee raise burn, lunar orbit insertion, descent orbit insertion, landing, and surface ops. From our lunar mission control in Washington, controllers execute real procedures, send commands into a flight representative sim, and read telemetry from an emulation of the global network of ground stations and satellites we'll use during the flight. So if you're not familiar with the Blue Origin Mark 1 lunar lander, here it is. It's 3 tons to the lunar surface. It's uncrewed and it's not refuelable. They also have a Mark 2. So let's have a look at that graphic. So I'll make it more obvious. So here in the left you have the Apollo lunar module that landed on the moon in the 1970s. Here is the Blue Moon Mark 1, which they should be launching to the moon soon, and that's the one they've been doing the simulations on. And then later, maybe next decade, I don't know when this launches, it's the crewed version, which is Blue Moon Mark 2, which is, as you can see, it's a much bigger vehicle, and it can land, I think it's 4 crew. I have another graphic here that I did for one of my videos on Blue Origin. So you can see the Mark 1 is 3 tons, not refuelable, and doesn't support humans. The Mark 2 is 20 tons in reusable mode and 30 tons expendable, and it can be refueled in near halo rectilinear orbit. That's around the moon, that weird orbit around the moon, and it does support humans. It's a human landing system. So another thing here is that the Mark 2 is reusable. That is, if you have propellant, either in orbit, in space, or potentially on the surface of the moon, you could refuel the lander and use it multiple times, and it's designed that way. Definitely exciting times for what's happening on the moon. We just had the Impulse Space basically announcing a lunar lander which competes directly with Mark 1. It's the same mass, 3 tons, except they are using storable propellants, while Blue Origin is much more interested in using liquid hydrogen and liquid oxygen, which have fantastic performance, high delta V, but there's some technical challenges they have to solve first. If you're familiar with their architecture, they have a cislunar transporter, which is kind of like a fuel shuttle. It can store liquid hydrogen, liquid oxygen in space, in orbit, for many, many months. It has a cryogenic management system to prevent boil-off. So it's very interesting times when it comes to the moon. Okay, so I now want to go on to the next company. And this is Momentus. They've been around a while. They've had a lot of problems. They've almost gone bankrupt a few times. They had to cut back on staff more than once. But they seem to be turning the corner now, and they're beginning to attract grants and contracts from the US government, Space Force, NASA. They've also got some commercial contracts as well. So things are picking up. So here's the article. It's Momentus expands NASA partnership with dual contracts for in-space manufacturing and propulsion demonstrations. They're saying they've secured 2 new NASA contracts totaling $7.6 million to advance space-based manufacturing and propulsion technologies. So the first award was for $5.1 million, and it's for the Commercial Orbital System for Microgravity in-Space Crystallization Mission, or COSMIC. And they'll be using their Vigoride orbital service vehicle as a hosting platform for cosmic payloads. In addition to that contract, they got another contract to conduct an on-orbit demonstration of their rotating detonation rocket engine, or RDRE for short. This is a new generation propulsion system that's been developed by Juno Propulsion under NASA's Space Technology Payload Challenge. And the thing about this RDRE thruster is it employs non-toxic, storable propellant, nitrous oxide and ethane. I just mentioned that Impulse Space is also using nitrous oxide and ethane. So that's 2 companies that are now using this new propellant formula, which is a storable, non-cryogenic propellant to stay in a liquid form in orbit for many, many months. So basically all you need to do is apply a small amount of pressure to keep it in its liquid form, and it will stay like that for many, many months, which makes the engineering a lot simpler. You don't need cryogenic systems or anything like that. They go on to say, this latest contract is the 6th we have awarded were being awarded in recent months by NASA. Momentus' growing role in the US government's technology pipeline. So that's very good news for Momentus, and as I say, they seem to be turning the corner. They're getting quite a few contracts, some R&D, some for deploying payloads in space using their Vigoride orbital transfer vehicle, as NASA calls it. It's basically a space tug, but it's water-based. So it uses hydrogen and oxygen, combining them to produce fuel. They basically deploy CubeSats up to 96U, and propellant tanks filled with water. So very simple propellant, just use water. Potentially the propellant you'd use to move around in space. Water you can get from asteroids, you can get it from the moon. It's widely available and abundant around the solar system. So if you've got efficient thrusters and engines that can use water, it's the perfect kind of fuel. This is what Blue Origin is using. They're using hydrogen and oxygen. So that can come from lunar sourced water or asteroids. Electrolyze the water into hydrogen and oxygen and use it for fuel. And they have the cislunar transporter vehicle to store that fuel for months. If I just show you this graphic, I did this graphic for actually another company called Orbital Operations, but they're also working on hydrogen and oxygen as propellant. So there's quite a few space startups now decided the optimum fuel to use to move around in cislunar space, the inner solar system, is hydrogen and oxygen. For instance, Orbital Operations can get water from the asteroids or from the moon. They can do commercial activities like Momentus is doing with their space tug for refueling, deorbiting commercial space stations, and water shuttles and water-based satellites. So you have Blue Origin's cislunar transporter that's being worked on now. You have Orbit Fab that are doing refueling missions. You've got Astroscale, Pale Blue I don't know much about, and then Momentus, all using water-based vehicles, space tugs, and landers. It's interesting that quite a few space startups are now coalescing on the use of water or hydrogen and oxygen as a propellant. On to our next story, Vast Space. They posted on X recently that two Haven 1 primary structures, the qualification and flight article side by side at Vast headquarters in Long Beach, California, all built in-house. Vast is bringing space station development back to the US to launch the world's first commercial space station and ensure a continuous American presence in low Earth orbit. There are the two vehicles, two articles, one of which is flight ready, one's just a qualification. So yes, built in-house in the US. Axiom Space, for instance, Thales Alenia in Italy build the habitation modules. We'll see what happens. They should be launching next year, probably second quarter of 2026. And that will be the very first commercial space station. They're now in a very good position because NASA is scaling back its requirements for commercial space stations. It's not going to the federal acquisition regulations, the FAR contracts, which are very complicated. It's staying with Space Act agreements, and there's going to be like 3 to 5 Space Act agreements. So Vast is almost certainly going to get one of those, and probably, I don't know, Starlab and Axiom Space, and who knows, maybe SpaceX with its Starship. So we'll see what happens over the next coming years, but I'm very positive about Vast Space. Okay, moving on to a company I'm not really familiar with, called Solstar, but they've been awarded by NASA a contract to develop lunar Wi-Fi system for the moon. So the contract value is $150,000, and it's to develop next generation lunar Wi-Fi access point to support the Artemis program. The Artemis spacesuit built by Axiom has Wi-Fi built into it, which means if there's a station, you'll get high definition video from the astronauts as they move around on the moon, which will be amazing. NASA is looking to deploy Wi-Fi and other communication technologies across a range of lunar assets. So it's not just lunar landers, it's rovers, it's, as I said, it's the astronaut suit, habitats, and also satellites and assets in lunar orbit, including the Gateway Station. The Solstar CEO said, "Receiving this Small Business Award is a milestone for Solstar and for space-based connectivity. We aim to bring commercial-grade connectivity to the moon, enabling seamless communication between crew, equipment, and mission control. We are proud to lead the way in developing the Wi-Fi backbone for the lunar economy." Okay, moving on to Exlabs. Space Force awards contract to Exlabs to advance persistent in-space infrastructure. So I've covered Exlabs in space news before. That was a partnership with Antares for nuclear reactors in space. Now they've got an award from the US Space Force, and it's for a next-generation spacecraft platform. The Department of Defense expanding interest in modular persistent infrastructure to accelerate in-space operations. And this is a heavy-class reconfigurable spacecraft. That's all it says in the article. We do know a few things about Exlabs. I'll bring up the video. This is from the website. So you can see it's quite a large vehicle, and it's modular. You can just keep adding modular sections to it. Here's another photo. So you can see how it's modular. You just keep adding these sections. They have solar panels, and you can build out quite a big spacecraft. They have partnerships. They have one with Antares, which is working on in-space nuclear reactors. So fission reactors. They're working on them for the surface of the moon, but also with Exlabs, potentially it could be nuclear-powered spacecraft. And they have quite a few partnerships already. Bring up this graphic from the website so you can see NASA, the Air Force Research Lab, Gravitics, which is building habitation modules for commercial space stations. SpaceWorks is also innovation office for the, I think, is it the US Space Force? So they have quite a few partnerships. So that's very interesting. And one more news item, and that is Stoke Space, who have just received a large amount of funding. Put myself in the corner. Has raised over $500 million to accelerate work on its fully reusable Nova launch system. So total capital raised now is $990 million, so nearly $1 billion in venture capital funding. And this will be to complete development and demonstrate Nova through its first flights. And that's expected to launch next year from Launch Complex 14 at Cape Canaveral Space Station in Florida. And this vehicle is capable of carrying lifting up to 20 tons of payload to orbit. A few interesting features about the launch vehicle is the second stage has a liquid-cooled heat shield. Our substantial manifest of contracted commercial launches. So if you're not familiar with the vehicle, here's an animation. That's the Nova vehicle. So you've got the first stage, got landing legs, and you've got the second stage here with the active for cooling here. And it's aerospike engine, which has never been demonstrated, I believe, commercially anyway. And here's the first stage landing legs, just like the Falcon 9. But also the second stage can land as well. So there's it deploying the payloads. Then the payload fairing closes, and it then re-enters, which is very difficult to bring back the second stage. But because you've got this active metal shield here, full of liquid hydrogen, it's very cold, and it keeps the vehicle within operating temperatures. It doesn't melt, and yeah, it propulsively lands. Because it's not using towels or anything like that, it can quickly be reused. Just a quick inspection, make sure everything's okay, refuel it, and it's ready to go again. So that is amazing. And here's a graphic of the second stage. So you've got the aerospike engine. There's could be 24 little thruster engines around the outside, and they kind of coalesce to create this kind of like virtual nozzle, which means it makes it very fuel efficient. And yeah, the heat shield is at the bottom. So a lot of new technology, a lot of innovation, and we'll see whether they can pull it off next year. So hopefully good luck with that, and then they can be another competitor to Falcon 9. So you've got SpaceX Falcon 9, you'll have Relativity Space with their Terran R vehicle, you'll have Rocket Lab's Neutron vehicle, which should be launching, I don't know, back end of this year or maybe next year, and then you'll have Stoke Space with their Nova vehicle. So that's 4 vehicles. So there's a lot of commercial space activity happening, and that's before you get onto the moon, and there's a lot of activity happening there. So anyway, thank you for joining or watching this space news video, and I will see you next week.